the application of differentiation. So we have had videos where we've talked about the chain, we've talked about the product rule. So this will be the first video. We have also a second part. First one, I just want to talk about the normal and the tangent to a curve. How do we find the equations of the normal and the tangent to the curve? Okay, so whenever you've been given a curve, it may be a quadratic function, it may be a polynomial function like the quadratic function, which is raised to the power 4, or the cubic function to the third power. So in this case, we have our curve, which is a cubic function. As you can see, it is able to cut the x-axis at 3 points. So what is a normal and what is a curve? So the normal to a curve is actually a line that cuts a certain point perpendicularly. So it makes an angle of 90 degrees. So in this case, the line that you're able to see in white is what we are calling what? The normal to a curve at that given point. Okay. So that is what we are calling what? The normal. Then the other point that is parallel to a certain point of on a curve is referred to as what? The tangent. So a tangent is any line that cuts a curve at one point. Okay. So now that we know what the normal and the tangent are, so we need to understand the relationship that lies between the normal with the curve. So I want you to understand that let M be what? The gradient of a curve. So let's say the gradient of a curve at that point is 2. How do we find the gradient of the tangent? So I want you to understand that the tangent, so the gradient of the curve is at a given point is equal to what? Is equal to the gradient of the tangent at that point. So let's say the gradient of this curve that I've drawn here is 2 at that point. We expect the tangent to also have what? To have a gradient of 2. How about the normal, which is perpendicular? So since the normal is said to be perpendicular, if you go back to our coordinate geometry, we expect the products, whenever two lines are perpendicular to each other, we expect that their product, the products of their gradients is supposed to be what? Is supposed to be equal to a -1. So in that case, where we have 2 being the gradient of the curve, we expect the gradient of the normal to be -1/2, so that if we multiply them, we are able to get what? A -1. Okay, so that is the introductory part of the application of differentiation. So let's try to have an example and try to find the gradient, even in trying to find the equation as well. So let's say we've been given that curve there, f of x is equal to x to the power 4 minus 4x to the third power. Then we are asked to find the tangent and the normal to the curve below at a point where x is equal to 1. So where x is equal to 1, how do we find the gradient? So let's first of all try to find their gradients. Okay, so I'm going to start with the tangent. Okay, so let's start with the tangent. So I said the tangent is a line that cuts or meets a curve at a given point. Okay, so remember that we say that the derivative of the dy x is also what? Refers to the gradient. So let's first of all try to find the gradient of that point where x is equal to 1. So dy x of that function is going to be equal to, so we know that by differentiation we're supposed to multiply the coefficient with a power. So in that case we're going to have 4x, the power should reduce by 1, which is going to be third power there. Then -4 by 3 is going to be -12. Then reducing the third power by 1 is going to be x squared. So that's our function, our derivative. But at a point where x is equal to 1, we have to substitute a value of 1 where we have x. So we're going to have 4 multiplied by 1 raised to the third power minus 12 multiplied by 1 the squared. So what are we going to have? So we're going to have 4 subtract 12, which is going to give us -8. So what is our gradient of that curve at that point? So we found the gradient to be -8. So what do we do to find the gradient of a tangent? So we said the gradient of a curve at any given point is also equal to what? To the gradient of a curve at that point. So we expect the tangent to also have what? A gradient of -8 at that point. Okay, so we found our m, which is our gradient, to be equal to -8. So now we are not interested in the gradient according to the question. The question is asking us to find the equation, so find the tangent. So we're trying to find the equation of our tangent, and we expect the tangent to be a line. So what do we do? So we have our gradient here. So we need to have so we've been given the x what? X coordinate. So let's find the y coordinate. So to find the y coordinate, you just have to substitute the value that you've been given in the original function. So which is going to be y is going to be equal to 1 to the power 4 minus 4 multiplied by 1 to the third power, which we know there will be no difference. So in this case, our y is going to be equal to what? 1 minus 4, which is equal to what? -3. So we found our y coordinate as well. So it's our x is equal to 1, then our y is equal to what? -3. Okay. So what do we do for us to find the equation now of the tangent? So I'm saying y is equal to -3. So now let's try to let's have some space here. Right. Okay, so let's try to find the equation. So the equation, how do we find the equation? From our knowledge of our coordinate geometry, we know that y is equal to, this is actually the form of a straight line, the equation of a straight line. We expect it to be y is equal to mx by plus c. So where our y in this case is -3, we found our gradient to be -8, then our x is 1, so plus c. So we're trying to find the constant c, the y component, or the y intercept, sorry. So in that case, it's going to be -3. -8 by 1 is -8. When it crosses others to the other side, it's going to be +8 plus c, or equal to c, sorry. So c. So therefore, our c is going to be equal to what? -3 plus 8 is what? 5. So we found our c to be equal to 5. We have our y. So for us to write the equation, our equation is going to be y is equal to, what is our gradient? Our gradient is -8. So it's going to be -8x plus what? Plus 5. So what is our tangent to the curve that we had in this question? So we found the equation of the tangent. How do we find the equation of a normal? So the steps are going to be the same, except the gradient is going to be different. And how do we expect the gradient to be? So our gradient is going to be, so we said since the normal is perpendicular, to the curve, we expect the product of the gradients to give us what? -1. So the product of a gradient of a curve multiplied by the gradient of the normal is supposed to give us what? A -1. So what is the gradient of a curve at that point? We found this to be -8. So we're going to substitute. So -8 multiplied by m2, it's just going to be m2, which is equal to -1. So for us to find m2, we divide by -8 both sides, and our m2 is going to be what? It's going to be equal to 1/8. So we found the gradient of what? Of the normal. Then how do we find the equation? We're going to go back to the same steps now. So take note of the gradient, very important as well. So our gradient for the tangent becomes positive 1 over 8. Okay, so let me just try to indicate that. So we have positive 1 over 8 as our gradient for the normal. So first to find, again, we know it's a straight line, of course. So y is equal to mx plus c. That is the general form of a straight line. Then what is our y coordinate? Our y coordinate is negative 3. What is our gradient? Our gradient is 1 over 8. What is our x? Our x is 1, which will not change anything. Okay. So to make our calculations easier, we multiply by 8 on both sides. We are going to have negative 24 this side. And here we're just going to have a 1 plus 8c. So trying to make c the subject, what are we going to have? So we're going to have negative 24 minus 1 is going to be negative 25 equal to 8c. So therefore our c is going to be equal to negative 25 divided by what? Divided by 8. So after this stage, you just go back now and try to substitute in the equation there. So we have our y there. So y is equal to, what is our gradient? Our gradient is 1 over 8. So it's going to be 1 over 8x minus 25 over 8, which is our c. So at this point of time, you need to be a bit advanced. You need to write your equation in this form. You multiply it by 8. We don't want fractions. So it's going to be 8y equal to x minus 25. So this is the equation for what? For the normal to the curve. So hopefully this video gave you an idea about the normal and the tangent. And whenever you're given a question in relation to you finding either the gradient or the equation of the normal and the tangent, I expect you not to have any challenges. So thank you very much for watching. Make sure to subscribe so that I continue making more of such videos to help one another. Thank you very much.